as discussed in earlier videos, you always want to pick the easiest way to solve a quadratic equation if you can, and I usually almost always look for factoring first. But if I'm spending too much time and I'm looking at this one and I cannot see that it factors, A is not 1, there's no GCF. This thing, I'm not seeing it, and it doesn't, and actually this one does not factor. So you might mess around with it a while and say, oh, it does not factor. Well, the only other method I've learned so far is by completing the square, and that was the method that was mathematicians had originally, and we're like, okay, well, we can solve this, but let's show that completing the square is a method that you would not want to use on this, and that's why I always recommend when A is 1 and that's even. Otherwise, don't use completing the square. So say I ask you to solve this and we go to use completing the square. First, I'd have to make A a 1. Right there is an issue. I start forcing this to be a fraction. It works, you can do it, but I have fractions already. Now A is 1. Now I go off to the side and I go 1/2 of B and I square it. So take half of B and square it, you're going to have a mess. You know, you'll end up with negative 3/4 squared is going to be a positive 9/16. You're going to add that to both sides. You're going to send your 7/2 to both sides. And I'm going to stop there. We do not want to do that. That's just a mess, and it's much, much more difficult. So many of you are probably familiar with the quadratic formula and may even remember it by song and that kind of thing. Well, that's why the quadratic formula was derived, because we need an easier way. We don't want to deal with all these, muddle through all these fractions and deal with that. Well, so what we do is just basically derive it from the standard form of ax squared plus bx plus c, and we complete the square of this thing, and when we complete the square of that and solve for x, we get the quadratic formula. So that's what I'm going to show you. I never ever am going to ask you to derive this, but I think it's important to see that, hey, my formulas aren't coming from thin air. This is coming basically directly from completing the square of a standard form, and it works for all then, and then I can, as long as I can identify A, B, and C, I can plug and chug. So that's what we're going to do, and then we can solve this problem not so badly with the quadratic formula. So let's go. First, I'm going to look at this, and I'm going to say, okay, mathematicians were like, wait a minute, man, we need an easier way. So I'm going to complete the square of this thing and follow those rules. Like I said, I'll never ask you to derive this, but this is only just for demonstration purposes to show you that it's where it comes from. So my first step was always get the constant on one side, make A a 1. I can do that either way here, but I'll just divide out A right away. I had to make that leading coefficient a 1. So I'm down to x squared plus b over a x space, and I have negative c over a. Now I have it in a form where I can do this. Now I take half of that and square it. So if I go off to the side here and I go, what's 1/2 of b over a squared? It's a mess, but you end up with b squared all over 4a squared. So I would have to add that to both sides. So I just completed the square of this thing. So now I can factor this down to the square of a binomial. What was being squared in front goes in front. Same sign here. What's being squared in the back, which is b all over 2a, goes in the back. And then over here, I'm going to rearrange these so the negative is in the back. So I'm going to have b squared over 4a squared. This I'd have, so we can combine these. Let's find the LCD, which is going to just be 4a squared, right? So I multiply this by 4a and a 4a, top and bottom. So I'll end up with minus 4ac all over 4a squared. Now you can subtract your tops, and you have an x plus b over 2a quantity squared is equal to b squared minus 4ac all over 4a squared. And some of you might be like, oh, it's starting to look like the quadratic formula, because you start to recognize some of the numbers, and it is. We're really close now. I use them as square root property, right? Square root property plus minus the square root of this side. And so this wipes out. X plus b over 2a One thing is I have a square root of a fraction, so what I'm going to do is individually break this up so that I can simplify it a little better. And that's a property we talked about in chapter 10, or the previous chapter of this material. And so square root of that bottom then is actually a perfect square, which becomes 2a. Square root of 4 and square root of a squared. And this ends up being, and let me write this here a little better. So this ends up being plus minus the square root of b squared minus 4ac all over 2a. So my very last step then is solve for x. I just subtract b over 2a to both sides. I put that in front of my plus minus. And I guess my plus minus, sorry. So subtract that and stick it in front. So you'll end up getting x equals negative b over 2a plus minus square root of b squared minus 4ac over 2a. They're the same denominator, so you can just write them as 1, negative b plus minus square root of b squared minus 4ac all over 2a. And that's the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Or think of it as opposite of b. So if b is negative, it becomes a positive when we plug it in. And that's the quadratic formula, and where it was just basically derived from completing the square, so we don't have to go through all of that issue of dealing with fractions and stuff. I'll never ask you to do that. I'm actually going to be giving you the quadratic formula, so I'm not worried about you memorizing that. But, so that is the quadratic formula.